right, so let's talk about, because we already talked about greatest common factor. We did that, but I want to kind of back up just a little bit, because some people were having a little bit of trouble distinguishing factors. So I want to talk about multiples, and then I want to talk about factors, okay? So first of all, I would like to say that there are a multitude of multiples. That means there are infinitely many. It just goes on and on and on. That's the sign for infinity. It never ends. Okay? So there is no end to those multiples. Numbers only count as factors or multiples when you multiply or divide by integers. Now, that's a word we haven't covered yet, and I didn't want to get too much into that, because that's when we get into positive and negative numbers and fractions and decimals and everything. So what I want you to remember is we're talking about regular whole numbers, not fractions, okay, and not decimals. Neither one of those. So not fractions, not decimals. So we've got 16 in the middle here, and it says to find multiples, we what? Well, let me tell you. It's kind of in the name. We multiply. So if I've got 16, I'm going to have 16, 32, 48, 64, 80, and so many more. See, when we're in the classroom, you can color them in yourself. But for now, I get to. Okay, so that's what we do when we multiply. Now, what about when we divide? Or what about factors? Factors are when we divide, okay? It's the opposite. Think of that. Multiply, divide, those are opposites. So the multiples are the opposite of the factors. So, we've got 16, so we're going to divide. 16 divided by 1 is 16. 16 divided by 2 is 8. And 16 divided by 4 is 4. Those are all of our factors for 16. Okay, so we said that there's a multitude of multiples, right? But let me tell you, there are a limited number of factors, okay? This is all the factors. There are no more for 16. That's it. Whereas our multiples, they just keep going and going and going and going. Okay? I want you to also remember that factors come in pairs. Okay? Off to the side there, factors come in pairs. You're always going to have a set of factors. Whereas multiples, it's just one after another, on and on and on. All right? So let's try this. We've got list all factors and the first four multiples of 72. So I'm going to do the factors of 72 first. Okay? So here's another way to do factoring. You can put 72 in the middle and then do 1 times 72. Kind of like a mind map when you're planning out your writing assignment. Okay, 2 times 36, 3 times 24, let's see, 4 times, trying to do this in my head, 4 into 7, 1, 3, so 18, 4 times 18, 6 times 12, oh, and 8 times 9. So those are all the factors of 72. Boom, 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 boom. All of those. All right. Now the first 4 multiples of 72. I'm just going to make a column. We've got 72, 144. Yeah, it's strain in my brain here. 216, and then 288. Ooh, you can't even see what I'm doing. Why didn't you tell me that? All right. So let's look at this. These are all the factors of 72. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12. Doesn't look like a 12, but it is a 12. And 8 times 9. So those are all the factors of 72. When we go with multiples, we're skip counting, basically. We're counting by 72. So 72, 144, 216, 288. Okay, so multiples is like skip counting. So let's do this one here. It says list the factors of 45. So the factors of 45. I'm going to do it this new way here, just because I think it's kind of cool looking. 45. I've got 1 times 45. And I've got 5 times 9. Oop, I forgot one. 3 times 15. 4, 5, 6, 7, 8, 9. So that's it. Those are all the factors of 45. Okay, last one on this side. We've got list 5 multiples of 8. Well, we're just going to skip count by 8. 8, 16, 24, because it's 8 times 1, 8 times 2, 8 times 3, 36, 40. There we go. 1, 2, 3, 4, 5. Those are the first multiples of 8. That's it. That's all it is to find multiples. Okay? So factors we're finding out by dividing this by individual numbers. This we're multiplying. Okay? So here's another side. Now notice I've got LCM here is NS2, and GCF I already told you was NS1. So I'm going to do this part here for GCF, then I'm going to come up to LCM, and then we're going to do the triads. Okay? So the first thing I want to tell you is that you need to remember to list your multiples or your factors. Step 1, list the multiples and factors. Right? Step 2, look for anything that matches. Okay? And then step 3, you're looking for the smallest or the biggest match. Okay? If it's a multiple, you're looking for the smallest. If it's a factor, you're looking for the biggest. That's what we want to remember. So let's give this a whirl, shall we? We've got find the LCM of 9 and 12. So since it's LCM, we're going to go with multiples. M for multiples. So we're going to skip count. 9, 18, 27, 36, 45. I'm going to stop at 45. I usually do like 5 of them, and then if it doesn't pan out, then I go a little bit further. So we'll go through there, and now we're going to do 12. 12, 24, 36. Hey, right there. Okay, so our LCM is 36, and so I put a box around it because that's how we know it's our final answer. That box is the final answer. All right, and we're going to remember that the least common multiple of 2 or more numbers is the lowest or smallest number that they both have. Okay, so the smallest number they had was 36. That's how we got our answer. You know what? I told you I was going to do GCF first and then LCM. Oh well. So I wasn't paying attention. And so let's do GCF. This should be just a quick review for you because we've done GCF. So remember that the greatest common factor of 2 or more numbers is the biggest number they both have. Okay, so our factors for 40, I'm just going to do this. Put my circle, and I'm going to do 1 times 40, 2 times 20, 4 times 10, 5 times 8, and that's it for 40. And I know this because I was going 1, 2, not 3, 4, 5, not 6, not 7. When I come back to 8 and I already have it, then I know I can stop because there's nothing else. 64. Will you still need me when I'm 64? 1 times 64. 2 times, not 36, 32. 2 times 32. Not 3, but 4 times 16. 5, 6, 7, 8. 8 times 8. There we go. So since I'm at 8, then we're going to go up and just keep going. So we're done with 64. Now we're going to look for what they have that are the same. Okay, so let's see. What do we have that's the same? We've got 1, 2, 4, 8, and that's it. So our GCF is 8 with the box around it. Woohoo! Okay? Hopefully this is making some sense to you. Now we've got these 3. What I want you to do is, I want you to try these on your own. I want you to pause the video, try it on your own, and then come back and check your answers, okay? So pause the video now. Really, I mean pause it. You haven't paused it. It's cheating if you don't pause it. Thank you so much for actually pausing the video for those that did. Right now, I don't have the technology to know whether you really did or not. So, I'm going to give you the answers, and then you can ask in class if your answer is not correct and you can't figure out why in the world my answer and your answer are totally different. All right? Here is the final answer for each and every one. Ready? This one, the GCF is 3. Number 2, the LCM is 63. And for number 3, the GCF is 14. So if you did not get those answers, you need to, Miss Issel, how come my answer didn't come out like that? Okay, because you actually have to be able to do this for the quiz. And you'll be getting a quiz on Wednesday. So there. All right. Go ahead and go into Teams. You've got an assignment to do for LCM and GCF. And I will see you soon.